This video is brought to you by Hover, a great place to find your personal domain online. Go to hover.com/brainfood and save 10% today. So, in the video today, we're answering a viewer question because Jeremy D asks us, and it's a big one, who invented the internet? While the World Wide Web was initially invented by one person, which we're going to get into in a bit, the genesis of the internet itself was a group effort by numerous individuals, sometimes working in concert and other times independently. Its birth takes us back to the extremely competitive technological contest between the United States and the USSR during the Cold War. The Soviet Union sent the satellite Sputnik 1 into space on October 4th, 1957. Partially in response to this, in 1958, the American government created the Advanced Research Project Agency, known today as DARPA, Defense Advanced Research Projects Agency. The agency's specific mission was to prevent technological surprises like the launch of Sputnik, which signaled that the Soviets had beaten the US into space. The mission statement has evolved over time. Today, DARPA's mission is still to prevent technological surprise to the US, but also to create technological surprise for our enemies. To coordinate such efforts, a rapid way to exchange data between various universities and laboratories was needed. This all brings us to J.C.R. Leckleider, who is largely responsible for the theoretical basis of the internet, an intergalactic computer network. His idea was to create a network where many different computer systems would be interconnected to one another to quickly exchange data, rather than have individual systems set up, each one connecting to some other individual system. He thought up the idea after having to deal with 3 separate systems connecting to computers in Santa Monica, the University of California, Berkeley, and a system at MIT. As he said, "For each of these 3 terminals, I had 3 different sets of user commands. So if I was talking online with someone at SDC and I wanted to talk to someone I knew at Berkeley or MIT about this, I had to get up from the SDC terminal, go over and log into the other terminal and get in touch with them." I said, "Oh man, it's obvious what to do. If you have these 3 terminals, there ought to be one terminal that goes anywhere you'd want to go where you have interactive computing. That idea is the ARPANET." So yeah, the idea of the internet as we know it partially came about because of the seemingly universal human desire to not have to get up and move to another location. And this, of course, proves yet again that laziness is the source of all invention. Alright, so with the threat of nuclear war, it was necessary to decentralize such a system so that even if one node was destroyed, there would still be communications between all of the other computers. The American engineer Paul Barron provided the solution to this issue. He designed a decentralized network that also used packet switching as a means for sending and receiving data. Many others also contributed to the development of an efficient packet switching system, including Leonard Kleinrock and Donald Davies. If you're not familiar, packet switching is basically just a method of breaking down all transmitted data, regardless of content, type, or structure, into suitably sized blocks, which are called packets. So, for instance, if you wanted to access a large file from another system when you attempted to download it, rather than the entire file being sent in one stream, which would require a constant connection for the duration of the download, it would get broken down into smaller packets of data, with each packet being individually sent, perhaps taking different paths through the network, which is, as alluded to, a key advantage of this sort of system. The system that downloads the file would then reassemble the packets back into the original full file. These and other ideas were all put together to form a system called the ARPANET, which was the principal precursor to the internet as we think of it today. It was installed and operated for the first time in 1969 with 4 nodes, which were located at the University of California at Santa Barbara, the University of California at Los Angeles, SRI at Stanford University, and the University of Utah. The first use of this network took place on October 29, 1969 at 10:30 p.m. and was a communication between UCLA and the Stanford Research Institute. As recounted by the aforementioned Leonard Kleinrock, this momentous communique, it went a little something like this. "We set up a telephone connection between us and the guys at SRI. We typed the L and we asked on the phone, 'Do you see the L?' 'Yes, we see the L,' came the response. We typed the O and we asked, 'Do you see the O?' 'Yes, we see the O.' Then we typed the G, and the system crashed, yet a revolution had begun. By late 1971, the number of computers that were connected to ARPANET had reached 23, and it was at this time that a computer scientist by the name of Ray Tomlinson came up with a new messaging system for ARPANET that would come to be called email. What Tomlinson was originally thinking of doing was simply implementing his own version of a little program called SendMessage. SendMessage ran on the 10X operating system and was essentially just one of the many flavors of single-computer email. In other words, an electronic mail system capable of sending messages from one user on a computer to another user on that same computer. While this might seem absurdly useless given the way people use computers today, back then programs like this were incredibly handy. For instance, the auto-DIN system created in the early 1960s had a facility for sending messages between users, and at its peak it handled nearly 30 million electronic messages every month. MIT's time-sharing system had something similar in the 1960s that allowed its numerous users to log in from some terminal and, among other things, exchange messages stored on a single machine. Tomlinson thought that it would be interesting to improve SendMessage such that it could not only be used for sending messages to other users who could log into the same machine, but also be used to send messages from one computer to another via the ARPANET. Tomlinson stated about this tweak to SendMessage to quote him, "Seems like a neat idea. There was no directive to go forth and invent email. The ARPANET was a solution looking for a problem. A colleague, Jerry Birchfeld, suggested that I not tell my boss what I had done because email wasn't in our statement of work. That was really said in jest because we were, after all, investigating ways in which to use the ARPANET." While writing the code for this, Tomlinson had to decide how to designate that a message should be sent to another computer on the network rather than a local account. He fatefully settled on the @ symbol, a symbol that only made it onto the standard keyboard in the first place because of its common usage in commerce. So why did he choose the @ symbol over any other symbol? Well, Tomlinson stated of this, "I looked at the keyboard and thought, what can I choose here that won't be confused with a username? If every person had an @ sign in their name, it wouldn't work too well, but they didn't. They did use commas and slashes and brackets. The purpose of the sign in English was to indicate a unit price, for example, 10 items @ $1.95, so it made sense. The @ symbol didn't appear in names, so there would be no ambiguity about where the separation between login and hostname occurred. The @ symbol also had no significance in any editors that ran on 10X. I was later reminded that the Multics time-sharing system used the @ symbol as its line erase character. This caused a fair amount of grief in that community of users. The resulting format he came up with was login name @host and later login name @host.domain once the DNS system was developed. And so it was that what is generally credited as being the first true network email, at least as we think of it, was sent in late 1971 by Tomlinson. The first message was sent between two DEC-10 machines that were literally side by side. The only physical connection they had, aside from the floor they sat on, was through the ARPANET. I sent a number of test messages to myself from one machine to the other. The test messages were entirely forgettable, and I have, therefore, forgotten them. Most likely the first message was QWERTY UIOP or something similar, essentially quickly randomly typing gibberish on the keyboard. When I was satisfied that the program seemed to work, I sent a message to the rest of my group explaining how to send messages over the network. The first use of network email announced its own existence. Alright, going back to the internet itself. Alongside these developments, engineers created more networks which used different protocols such as X25 and UUCP. The original protocol for communication used by the ARPANET was NCP, or Network Control Protocol. The need for a protocol that would unite the many networks was needed. In 1974, after many failed attempts, a paper published by Vint Cerf and Bob Kahn, also known as the fathers of the internet, resulted in the protocol TCP, Transmission Control Protocol, which by 1978 would become TCPIP, with the IP standing for Internet Protocol. At a high level, TCPIP is essentially just a relatively efficient system for making sure the packets of data are sent and ultimately received where they need to go, and in turn assembled in the proper order so that the downloaded data mirrors the data in that original file. So for instance, if a packet is lost in transmission, TCP is the system that detects this and makes sure that the missing packets get resent and are successfully received. Developers of applications can use this system without having to worry about exactly how the underlying network communication works. On January 1st, 1983, Flag Day, TCP/IP would become the primary communication protocol for ARPANET. Also in 1983, Paul Mockapetris proposed a distributed database of internet name and address pairs known as the Domain Name System, or DNS. This is essentially a distributed phone book linking a domain's name to its IP address, allowing you to type in something like TodayIFoundOut.com instead of the IP address of the website. The distributed version of the system allowed for a decentralized approach to this phone book. Previous to this, a central hosts.txt file was maintained at Stanford Research Institute that then could be downloaded and used by other systems. Of course, even by 1983, this was becoming a bit of a problem to maintain, and there was a growing need for a decentralized approach. This brings us to 1989, when Tim Berners-Lee of CERN, derived from the French console European pour la recherche nucléaire, sorry French people, that was disastrous, also known as the European Organization for Nuclear Research. They developed a system for distributing information on the internet, and they renamed it the World Wide Web. What made this system unique from existing systems of the day was the marriage of the hypertext system, linked pages, with the internet, particularly the marriage of one-directional links that didn't require any action by the owner of a destination page to make it work, as with bidirectional hypertext systems of the day. It also provided for relatively simple implementations of web servers and web browsers, and was a completely open platform, meaning that anyone could contribute and develop their own systems without paying any royalties. In the process of doing this, Berners-Lee developed the URL format, hypertext markup language, HTML, and the hypertext transfer protocol, HTTP. Around the same time, one of the most popular alternatives to the web, the Gopher system, announced it would no longer be free, effectively killing it, with many switching to the World Wide Web. Today, the web is so popular that many people often think of it as the internet, even though this is not the case at all. The next momentous point in internet history rolls along in 1993. Mark Andreessen, he led a team that developed a browser for the World Wide Web named Mosaic. This was a graphical browser developed via funding through a US government initiative, specifically the High Performance Computing and Communications Act of 1991, which is also known as the Gore Bill. This is the act Gore was talking about in his infamous Wolf Blitzer interview, where many claimed that he said he invented the internet. Even though his actual quote was, "During my service in the United States Congress, I took the initiative in creating the internet. I took the initiative in moving forward a whole range of initiatives that had proven to be important to our country's economic growth and environmental protection, improvements in our educational system." This extremely poorly worded sentence, "I took the initiative in creating the internet," taken out of context and using the common rather than the political definition of initiative, caused confusion and allowed opponents to construe that he said he invented the internet. This isn't what he was trying to say at all when it's viewed in context. That's pretty obvious. But of course, in politics, it does not matter what you were trying to say. It only matters how your opponents can twist your words, either to make you look like the devil, an idiot, or a liar. Alright, all political wrangling aside, this bill was hugely important to the advancement of the internet, funding a variety of internet-related projects and infrastructure, with, again, among many other things, funding being provided to Mark Andreessen and company to make the Mosaic web browser. Gore would continue to push for the expansion of the internet, and also particularly push for access for all to it, noting in 1994, "We've got to get it right. We must make sure that all children have access. We have to make sure that the children of Anacostia have that access, not just Bethesda, Watts, not just Brentwood, Chicago's West Side, not just Evanston." That's not the case now. 22% of white primary school students have computers in their homes, less than 7% of African American children do. We can't create a nation of information haves and have-nots. The on-ramps to the information superhighway must be accessible to all, and that will only happen if the telecommunications industry is accessible to all. As one of the fathers of the internet, Vincent Cerf, said, "The internet would not be where it is in the United States without the strong support given to it and related research areas by Al Gore in his current role and in his earlier role as senator. As far back as the 1970s, Congressman Gore promoted the idea of high-speed telecommunications as an engine for both economic growth and the improvement of our educational system. He was the first elected official to grasp the potential of computer communications to have a broader impact than just improving the conduct of science and scholarship. His initiatives led directly to the commercialization of the internet, so he really does deserve credit." Alright, so going back to Mosaic. Now, this was not the first web browser, as you'll sometimes read. It was simply one of the most successful until Netscape came around, which was developed by many of those who had previously worked on Mosaic. The first ever web browser, called World Wide Web, was created by Berners-Lee. This browser had a nice graphical user interface, allowed for multiple fonts and font sizes, allowed for downloading and displaying images, sounds, animations, movies, etc. It also had the ability to let users edit the web pages being viewed in order to promote collaboration of information. However, this browser only ran on Next Steps OS, which most people didn't have because of the extremely high cost of these systems. This company, you might not be surprised to learn, was owned by Steve Jobs, so you can imagine that cost bloat. In order to provide a browser anyone could use, the next browser Berners-Lee developed was much simpler, and thus versions of it could quickly be developed to be able to run on just about any computer, for the most part regardless of processing power or operating system. It was a bare-bones inline browser, command line and text only, which didn't have most of the features of his original browser. Mosaic essentially reintroduced some of the nicer features found in Berners-Lee's original browser, giving people a graphical interface to work with. It also included the ability to view web pages with inline images instead of in separate windows as other browsers of the time allowed. What really distinguished it from other such graphical browsers, though, was that it was very easy for everyday users to install and use. The creators also offered 24-hour phone support to help people get it set up and working with their respective systems. Given how easy Mosaic was to install and set up and how feature-rich it was, it became extremely popular, helping the web to dominate its other competitors into oblivion, as well as significantly aid in the growth of the internet in general. And, well, the rest, as they say, is history. And, well, you can be a part of that history with today's sponsor, Hover, and I want to tell you a little bit about them before I get into the bonus facts today. Hover are a great place to find your personal domain online. Having that is vital for developing yourself as well as your personal brand. Also, Hover doesn't badger you with a dozen upsells. In fact, whois privacy, something normally charged for, is free. And if you run into any trouble, you probably won't though, their customer service team is ready to help you out. Once you've bought your domain, you can connect it to your website builder in just a few clicks. And they've got lots of domain extensions. Of course, there's the .com and all of that good stuff, but there's also a lot of fun ones. There's .ninja, .rocks, .wtf, loads of options. So again, that's Hover. Just go to hover.com/brainfood to save 10%, link below, and let's get into those bonus facts. The double forward slashes in any web address serve no real purpose, according to Berners-Lee. He only put them in because it seemed like a good idea at the time. He wanted a way to separate the part the web server needed to know about, for instance www.TodayIFoundOut.com, from the other stuff, which is more service-oriented. The double forward slash seems natural, as it would to anyone who's used Unix-based systems. In retrospect, though, this was not at all necessary, so the double forward slash is essentially pointless. And now for another bonus fact. Berners-Lee chose the name World Wide Web because he wanted to emphasize that in this global hypertext system, anything could link to anything else. Alternative names he considered were Mine of Information, MOI, The Information Mine, TIM, and Information Mesh, which he discarded as it looked too much like Information Mess. And now for another bonus fact. Pronouncing www as individual letters takes 3 times as many syllables as simply saying World Wide Web. So I really hope you found that video interesting. Hopefully we answered that question that was posed all the way back at the beginning, which seems like a long time ago. This was a long video. I really hope you like it. Do click that like button, subscribe, all of that good stuff. Don't forget to check out Hover. There's a link to them below. And as always, thank you for watching.